Let's get started on Chapter 12, the Domain Name Service, DNS. In this chapter, we will be studying DNS Architecture, Host Name Resolution, the DNS Client, and the DNS Server. We will look at creating zones and at adding host records to zones. We will look at forwarding, DNS caching, and integrating DNS and DHCP. We will look at the different types of resource records, at fault tolerance, at reverse name resolution, and at integrating DNS and Active Directory. So let's start out with understanding the DNS architecture. The DNS architecture is a hierarchical method of organizing computers. At the top of the DNS architecture, we have the root. The root is divided into top-level domains such as .com, .net, .gov, .org, .mil, and .edu. And then top-level domains are divided into secondary-level domains such as Cisco, Walmart, or Microsoft, or EDU could be subdivided into Harvard, Princeton, and the Community College of Baltimore County. A host name is the name of the computer, and an example of a host name might be Server 1, or Database Server, or Accounting Server, or you could just call the mail server mail. And the most commonly used host name for a web server is www. The top-level domain includes .com, .edu. Secondary-level domain contains Cisco, Microsoft, and Walmart, and under EDU would be Harvard, Princeton, and CCBC. And then when we put together the top-level domain and the secondary-level domain and the host name, we get what's called the fully qualified domain name. The fully qualified domain name is the host name plus the secondary-level domain plus the top-level domain. If you want, you can even divide your existing domain into subdomains. We could divide CCBC into Essex, Dundalk, and Catonsville. Understanding DNS communications really means understanding what is meant by host name resolution. DNS is all about host name resolution. So let's take a look at what is meant by host name resolution. Host name resolution involves the following components: the DNS client, which is also called a resolver, a web server, a host name, a packet, an IP address, and a DNS server. So if a user wants to access the web page on a server, such as our web page here at CCBC, and the IP address of the web server was 10.0.0.5, then the user could type http://10.0.0.5. And if he pressed the enter key, then the IP protocol would send a packet, and the packet header would show that it's going to 10.0.0.5. The packet would go to the web server, and the web server would send the web page back. So how would the TCP/IP protocol know to send a packet to 10.0.0.5? Well, that's pretty obvious because that's what the user just typed. If the user types http://10.0.0.5 and presses the enter key, then the IP protocol will send a packet to 10.0.0.5, and that's the web server. But the thing is, people usually do not access web servers by IP address. I mean, they could if they wanted to, but they usually don't. The user usually types in the host name. User usually types www.ccbc.edu and presses the enter key. And then the IP protocol sends a packet to the web server, and the packet header shows 10.0.0.5. The packet header does not contain the host name. A packet header only contains the IP address of the destination computer. So if the user types ccbc.edu, how does the IP protocol know to send a packet to 10.0.0.5? And the answer is it asks the DNS server. A DNS server is a server with a list of all of the web servers within our organization and their corresponding IP addresses. So if the user types www.ccbcmd.edu and presses the enter key, well, the user doesn't know this, but the IP protocol sends a query to the DNS server. The query is a question. The IP protocol says to the DNS server, what's the IP address of ccbc.edu? The DNS server has host records. Host records list the name of the web servers and their corresponding IP addresses. So the DNS server sends the IP address of the CCBC web server down to the local workstation, and now the IP protocol sends a packet to that IP address at 10.0.0.5. The client types in the IP address of the web server, which you could call a host name or you could call it a URL, and a query goes to the DNS server. The DNS server has host records, that is to say computer names and the corresponding IP addresses, and the DNS server sends the IP address of the web server back to the workstation, and then the workstation knows to send a packet to 10.0.0.5. That's how TCP/IP knows that when the user types ccbc.edu, it knows it should send a packet to 10.0.0.5. This is hostname resolution. It's what DNS is all about. If people could remember IP addresses, then we wouldn't need hostname resolution. But usually people remember computer names, not IP addresses. Configuring the DNS client. To configure the DNS client to forward requests to the DNS server, in other words, when the user types ccbc.edu, we want the workstation, the DNS client, to push the requests to the DNS server. So to configure the client to push the requests to the DNS server, we go in the TCP/IP protocols of the client. Now you already know what the IP address is and the subnet mask and the default gateway. The fourth variable we type in here is the IP address of the DNS server. And when we type in the IP address of the DNS server, it tells the client that any DNS queries are going to be pushed to this IP address, 10.0.0.150. Now, suppose we make a typographical error. Suppose we accidentally type 151. If we accidentally type 151, then where is the DNS client going to send queries to? Well, it sure as heck is not going to be the DNS server. So make sure that when you configure TCP/IP on the workstation, that you do not have any typographical errors, because if you don't have the right IP address of the DNS server, then the client queries are not going to go to the DNS server. So after we've configured the DNS client to point to the DNS server, then all user queries will be pushed to the DNS server. So the main point in DNS is that the client asks the DNS server the IP address of the web server. Now let's look at deploying the DNS server. To deploy the DNS server, first we have to install the DNS server role. Then we create a zone which holds all the host records, and then we add the host records. So the first thing to do is go to Server Manager, and under Manage, we click on Manage, and then we select Add Roles and Features. In the Add Roles and Features wizard, We click on Next, and we select Role-Based Installation, followed by Next. Then we select the server onto which we want to install the DNS service, followed by Next. And then we select the DNS server. We click on the checkbox next to DNS server, and we see the description shows that the domain name service server provides name resolution for TCP/IP networks. We click on Next. Don't add any additional features. Click on Next, and we see the description shows DNS, domain name service, provides a standard method for associating names with numeric internet addresses, meaning IP addresses. This makes it possible for users to refer to network computers by using easy-to-remember names instead of a long series of numbers, meaning IP addresses. So I click on Next. We click on Install, and then that installs the DHCP service. And now you can see, did I say that installs the DNS, then that installs the DNS service. So DNS service is now installed. So the next thing for us to do is to go to the DNS server, go to the DNS Management Console, and to create zones and add records. To get to the DNS Management Console, we click on Tools and we slide down and select DNS. And this is the DNS Management Console. And if I expand it, I can see initially nothing's been added to DNS. There are no zones. So I select Forward Lookup Zones, and I right-click, and I want to select New Zone. I click on New Zone, and it says, Welcome to the New Zone Wizard. A zone translates DNS names to related data such as IP addresses. So a zone holds resource records. I click on Next, and I will make it a primary zone. Now, when I install a secondary DNS server for fault tolerance, I would select secondary zone. We'll talk about Active Directory zones later. For the moment, we will select a primary DNS zone, followed by Next. Then we type the zone name, which is typically going to be your organization's domain name. In our case, it'll be ccbcmd.edu. We click on Next, and then it creates a zone file. This is a text file that holds all the DNS information with an extension of .dns. We click on Next, and under Dynamic Update, which we will discuss in greater detail later, we select Allow both non-secure and secure dynamic updates. Click on Next. Then it says it's going to create a new zone, and it'll be a primary forward lookup zone. We click on Finish, and there is our new zone. And you can see one host record was automatically added to the zone, and that's Server 1, because we are on Server 1. Server 1 is the DNS server, so you can see that host record was automatically added to the zone. It shows Server 1 has this IP address. So now we've created a zone. The next thing to do is to add host records. So to add host records, we go to the zone, and we right-click, and we select New Host. They call it a host record. They also call it an A record, and the A stands for address, IP address. Quad A is for IP version 6. So I select New Host Record. So the point of host records is you're typing in the IP address of every web server in your organization and its corresponding name. So I type in the name of the web server, which is www. Notice I don't need to type ccbcmd.edu. That's already filled in for me because I'm already putting it in that zone. Then I type in what the IP address is of our web server, and I click on Add Host, and I click on OK. So now you can see if somebody types www.ccbcmd.edu and presses the Enter key, they will be directed to this IP address. Another example, I right-click and select New Host Record, and in this case, I have a server, a mail server, and the name of the mail server is simply mail. And I don't need to type ccbc.edu, that's already added, that's the FQDN, fully qualified domain name. And then I type in the IP address of the mail server, followed by add host, and OK. So if somebody types mail.ccbcmd.edu, they will be directed to this IP address. So DNS configuration. You install the DNS service, then you go to the DNS Management Console, then you create a zone, and then you add host records. There are three methods of adding host records to the DNS server: graphical user interface, command line interface, and automatically using dynamic DNS. Now, the graphical user interface method we just did. You use the DNS manager and you right-click on the name of the zone and you select new host. That's one way to go. But another way to go is to add host records from the command line, and this is what you would do if your DNS server were on a server core server. So you go to the command line, and to add a new host record to the DNS server, you type DNS CMD server1 record add www.ccbc.edu followed by A, indicate that it's an address record, followed by the IP address of that server. Press the enter key, and that adds the record to the DNS server. To add the IP address for the mail server, I'll type DNS command, DNS CMD. So what this means is we're going to add a record to server 1. The name of the record will be mail. It would be in the zone called ccbc.edu. It is an address record or a host record, and that's the IP address of the mail server. And then a third way of adding host records to the DNS server is automatically using DNS, dynamic DNS. Dynamic DNS is configured by going to the TCP/IP protocols and then going down to the bottom and clicking on the advanced button. And then we see a tab that says DNS. We click on the DNS tab, and down at the bottom of the page we see a checkbox that says register this connection's address and DNS. And that way, when this computer boots up, it'll automatically add its name to the DNS server. Three ways of adding hosts to the DNS zone: graphical user interface, command line interface, or automatically using dynamic DNS. So DNS performs host name resolution. Host name resolution means at the DNS client, the user types in a host name. The DNS client then sends a query to the DNS server. The DNS server contains host records, meaning computer names and their corresponding IP addresses, and the DNS server then sends the IP address back to the client. This is called hostname resolution. It's what DNS is all about. And this concludes part